Uh, Good morning, students. So, during your practicals, we are performing some synthesis. Okay, we are now in this video. We will come to know what are the principle. Or next synthesis is 2,3 diphenyl quinosaline. Quinosaline. Okay, so that is the synthesis of 2,3 diphenyl quinosaline. So this the principle behind this synthesis is that the condensation of aryl 1,2-diamine and 1,2-dicarbonyl compound in the heating solvent like rectified spirit. Hence, the condensation reaction of 1,2-diamine with diketones occurs. Okay, so here you can observe this structure. Okay, so this structure you can observe this hydroxy group, this oxygen. These are the carbonyl groups. So they are called as 1, 2 dicarbonyl groups. So here you can find out 1, 2 dicarbonyl group. So this is 1, 2 dicarbonyl group, and we are adding orthophenylene diamine. So that is the 1, 2 diamine. So this is benzene ring, so aryl and 1, 2 diamine. So this reaction is the reaction between 1, 2. This is 1, 2 dicarbonyl compounds with 1, 2 diamines, or you can say aryl 1, 2 diamines. Okay, and this reaction generally takes place in the presence of rectified spirit. Okay, so what happens when we are taking this drug? It is the benzyl. Okay, actually the double bond O by this. So when benzyl is there, it will react with the H plus ions, and when it reacts with the H plus ions, so this H plus ions bonds to one of the double bonded oxygen. So either this oxygen or second one this oxygen. So they form the hydroxy group. So here hydroxy group formation takes place. That is the first step. In the second step, the orthophenylene diamine, that is the diamine or aryl 1, 2 diamine, it reacts with the this one. Okay. So this oxygen and this hydrogens, it is removed in the form of water molecule. Okay. So this hydroxy group and this hydrogen, it is removed in the form of water molecule, and when they are removed in the form of water molecule, this type of bonding between the nitrogen and this carbon takes place. So you can observe here this amine group binds with this carbon, and when the binding of the carbon takes place, this hydroxy group and one of the hydrogen group, it is removed in the form of water molecule. So NH2 is converted into NH. This carbon will have all other groups as it is. Okay, so that is the second step. In next step, what happens? Here hydroxy group is present, here hydrogen is present. Again they react together and they emits water molecule, and when the water molecule is removed, double bond is created. So you can observe this double bond between this nitrogen and this carbon. That is the third step. In next step, again in the presence of H plus ions, this hydroxy group, it will get H plus ions, so it forms O plus H2. When they got O plus H2, they are removed in the form of water molecule, and we are getting this type of structure. And finally this hydrogen is also removed, and when this hydrogen is removed, with hydroxy group, here double bond is formed. That is the final structure, that is the 2,3 diphenyl quinosilane. So in this way, in the multiple step, the 1,2 di 1,2 dicarbonyl compounds reacts with the 1,2 diamines or aryl diamines to form a final product, that is the 2,3 diphenyl quinoxole. Okay, this used for antiviral, antibacterial, anti-inflammatory. They are also useful as anti-protozoal, anti-cancer, anti-HIV agents. So they have the multiple uses of these 2,3 diphenylquinoxaline drug. So this is the mechanism takes place. Now we will move to the next part of the synthesis, that is the synthesis of drug phenytoin. So generally it is synthesized from benzene and urea. So benzene plus urea in the form of ethanol and sodium hydroxide cyclization reaction takes place and they form the phenytoin reactions. That is the general reaction for the synthesis of phenytoin. Now mechanism, we can find out that first we are taking the urea and to the urea we are adding the sodium hydroxide. So what happens when we are adding the sodium hydroxide? So two molecules of sodium hydroxide are required. So one hydroxide reacts with the one hydrogen to form water molecule. Another hydroxide reacts with this hydrogen to form the water molecule. So we are getting NHCO C double bond NH plus two water molecules. So two water molecules are generated. So in the first step, the sodium hydroxide, it reacts with the urea. So one of the hydrogen and one hydroxy group gives one water molecule. Another molecule of hydroxy group plus hydrogen, it gives the second water molecule. So in this way, the two water molecules, they are synthesized, and during that we are getting the NH, and on nitrogen negative charge is present. This nitrogen, the negative charge is present. That is the first step. In the second step, this NHCO NH, nitrogen having the negative charge, it reacts with the benzene molecule. So benzene molecule consists of C double bond O, C double bond O diketone, and these are the two phenyl rings are present. So when phenyl rings are present, these two carbon, one carbon binds to the this, then the second carbon bind to this nitrogen. So here you can find out one carbon bind to this nitrogen, another carbon binds to this nitrogen. So this is the end product of the second step, or you can say that is the intermediate form during the second step. Okay. So that is the product of the second step. Third step, that is the in presence of H plus ions. Okay, so here we can see we are adding the ethanol also as well as the NaOH also. So during that we are adding the water molecule which provides the H plus ions. This H plus ions reacts with this intermediate. So H2 is present, 2H plus molecule are present. Okay, so one binds with this oxygen to form this hydroxy group. Another hydrogen bonds to this oxygen group to form the hydroxy group. Okay, so that is the step. And finally, the phenyl shifting takes place, or the shifting of phenyl molecule or shifting of phenyl group takes place. That means this phenyl group is shifted to this carbon, this hydroxy group shifted to this carbon. Now this carbon will have two hydroxy groups and another carbon, it will have two phenyl groups. Actually here it is not present, it is only double bond O. So when this carbon having two hydroxy groups, it undergo condensation reaction to form the water molecule, and only double bond O is remaining on this ring. And this is the final structure of drug phenytoin. So in this way, in the 3 steps, this urea is converted along with the benzene into the drug phenytoin. Okay. So first reaction or the first step is the NaOH reacts with the hydrogen. NaOH, this hydroxy group, this hydrogen, water molecule, this hydroxy group, this hydrogen, water molecule. So 2 water molecules are formed. So we are getting this NHCO, NH, nitrogen over negative charge. So this type of structure is formed. In the second step, this first intermediate reacts with this benzene ring. They consist of 2 phenyl rings. So this nitrogen binds to this carbon, this nitrogen binds to this carbon. We are getting the cyclization reaction and we are getting this product. In the next step, the shifting takes place, and during the shifting, this phenyl ring is shifted towards this carbon and this hydroxy group towards this carbon. So now this carbon it consists of 2 hydroxy groups. So एका कार्बनवर 2 hydroxy group कधीही राहत नाही. So OH and this hydrogen it is removed in the form of water molecule. So ह्या कार्बनवर फक्त हा ऑक्सिजन राहतो. So this carbon having only the oxygen. हे इथं काय नसतं. So this is the structure of the final product, that is the phenytoin. So in this way the synthesis of phenytoin takes place. This is the reaction mechanism for the synthesis of phenytoin. Next is the synthesis of drug benzocaine. So this benzocaine is the ester, and as I have told you that the ester is formed when acid reacts with alcohol. So the formation of ester takes place. So for benzocaine is ester, it requires 1 acid, 1 alcohol. So this para-amino benzoic acid. So para position ला amine group असल्यामुळे para-amino and this benzoic acid. So the para-amino benzoic acid and reacts with the ethanol to form the drug called as benzocaine. So that is the general reaction behind the synthesis of benzocaine. That is the general esterification reaction, and this esterification reaction is always takes place in the presence of sulfuric acid. Okay, so benzocaine is synthesized by Fischer esterification reactions in which carboxylic acid and alcohol converted into the ester, and this generally takes place by using the sulfuric acid. So that is the acid catalyzed nucleophilic reaction. Generally this reaction is the reversible reaction. What is meant by reversible reaction? So acid plus alcohol it forms ester. Similarly, ester again converted into acid plus alcohol. So reactant gives product. Similarly, product gives reactant. So आपले reactant कुठले आहेत? acid plus alcohol. Product कुठला आहे आपला? benzocaine, that is the ester. So acid plus alcohol घेऊन तुम्हाला benzocaine मिळेल. Simultaneously तुम्हाला benzocaine चा hydrolysis होऊन परत acid आणि alcohol मिळेल. So that is the reversible reaction, and it is having very slow speed. And after attaining the equilibrium, the rate of forward reaction or the rate of backward reaction becomes equal. So generally, to get the more amount of product, we are generally using the excess amount of acid because it is a reversible reaction. Okay, since sulfuric acid is in the esterification, benzocaine is available in the salt form. Okay, so sodium carbonate we are adding to maintain the proper pH. So this is the principle behind the esterification reaction, that is the benzocaine synthesis. So reversible reaction आहे. So reversible reaction असल्यामुळे प्रोडक्टचं परत रिएक्टंट मध्ये कन्वर्ट व्हायची शक्यता असते. त्यामुळे एक कुठला तर रिएक्टंट आहे, जनरली द ऍसिड आहे. ऍसिडचं कॉन्सन्ट्रेशन हे आपण जास्त अमाऊंट मध्ये टाकतो जेणेकरून बॅकवर्ड रिएक्शन आहे किंवा रिव्हर्स रिएक्शन आहे ती स्लो होईल. So that is the principal mechanism. So H2SO4 म्हणजे H plus HSO4 minus. H2SO4 चं conversion हे H plus आणि HSO4 minus मध्ये होतं. So this H plus add to this oxygen. So we are getting two hydroxy groups on one carbon. Then this carbon is attacked by the ethanol. So when it is attacked by the ethanol, so you can find out here this type of product is formed. Then the hydrogen, this hydrogen of alcohol, it is removed with the remaining HSO4 minus. So it again form the H2SO4 plus. Again this H plus ions, this hydroxy group, it is converted into water molecule, and this bond, it is converted into the double bond. And finally this hydrogen is removed in the presence of HSO4 minus. So H2SO4 is generally converted into H plus and HSO4 minus. So H plus ions ह्या ऑक्सिजनला जाऊन बाइंड होतात. ह्या ऑक्सिजनला जाऊन बांधले की ह्या कार्बनवर दोन हायड्रॉक्सी ग्रुप असतात. नेक्स्ट स्टेपला काय होतं, जो इथेनॉल आहे तो इथेनॉल जाऊन ह्या कार्बनला बाइंड होतो. सो वी आर गेटिंग दिस टाइप ऑफ प्रोडक्ट. त्याच्यानंतर इथेनॉल मधला जो हायड्रोजन आहे हा HSO4 जो तयार झाला त्याच्यावर रिॲक्ट होऊन तुम्हाला H2SO4 मिळतो आणि तुम्हाला हा प्रोडक्ट मिळतो. परत काय तो H2SO4 मधला H प्लस आणि हा हायड्रॉक्सी ग्रुप इट इज रिमूव्ह इन द फॉर्म ऑफ वॉटर मॉलिक्यूल. सो यू आर गेटिंग दिस टाइप ऑफ प्रोडक्ट. पण डबल बॉन्ड OH आहे, बरोबर आहे. सो इथला H प्लस गेल्यामुळे इथं परत HSO4 मायनस राहतं, त्याला हा हायड्रोजन जाऊन बाइंड होतो आणि डबल बॉन्ड OH चं कन्वर्जन फक्त O मध्ये होतं आणि यू आर गेटिंग द फायनल प्रोडक्ट दॅट इज द benzocaine. So that is the esterification reaction takes place. So in this way, the esterification of the benzoic acid or the paramer benzoic acid to the benzocaine takes place. That is the principle and the mechanism behind the synthesis of benzocaine. So benzocaine is the anesthetic agent. Then we are moving to the next synthesis, that is the synthesis of phenothiazine. So as the name indicates, these are the phenyl group. This is the thiazine. Thia means sulfur, azine means nitrogen. So both are present in this ring. So it is called as phenothiazine. So the central ring is the thiazine ring. So during practical we have seen that we are adding the sulfur, then we are adding the iodine, and we are performing the practical. So AlCl3 or iodine. एक तर AlCl3 ॲल्युमिनियम क्लोराईड वापरू शकतो, ट्रायक्लोराईड किंवा आयोडीन वापरू शकतो. त्याचा उपयोग फक्त कॅटलिस्ट म्हणून आहे, त्याचा ऍक्च्युअल रिएक्शन मध्ये यूज नाही. सो हिअर वी आर युझिंग द iodine as a catalyst. Okay, so phenothiazine is prepared by diphenylamine. So diphenyl means 2-phenyl and this is amine. So diphenylamine reacts with the sulfur and during the reaction आपल्याला कळालेलं आहे की H2S गॅस आहे तो रिलीज होतो. Now here one sulfur, actually it requires 2 molecules of sulfur for the reaction. Okay, so इथे ह्या कार्बनला एक हायड्रोजन असतो, ह्या कार्बनला एक हायड्रोजन प्रेझेंट असतो. So when sulfur is added and iodine is added, iodine acts as a catalyst. So this H2 and this sulfur is formed as the H2 gas. आणि दोन सल्फर मॉलिक्यूल मधला एक सल्फर हा जो H2SO मध्ये येतो, उरलेला जो सल्फर आहे तो इथे अटॅच येतो आणि सायकलायझेशन रिएक्शन होऊन तुम्हाला मधली रिंग सुद्धा सायकलाइज झालेली दिसते. सो दॅट इज द formation of phenothiazine takes place. That is the simple mechanism behind the phenothiazine synthesis. So फक्त दोन सल्फर वापरतात एवढं लक्षात ठेवा. एक सल्फर आणि हे जे दोन हायड्रोजन आहेत H2S तयार होतो, उरलेला सल्फर आहे तो इथे बाइंड होऊन तुम्हाला phenothiazine चे स्ट्रक्चर आहे ते मिळते. Now we are moving to the final part of your periodic syllabus or the sessional syllabus of practical, that is the assay of ibuprofen. Generally, the assay is performed to find out the percentage purity of ingredients present in the given sample. So first assay is the assay of ibuprofen. So this is the structure of ibuprofen. So this is the information regarding the ibuprofen. Ibuprofen is the analgesic. Okay. So ibuprofen, ibuprom, न्यूरोफेन, मोडाफेन, आयबुमॅक्स बऱ्याचपैकी जी मार्केटिंग एजन्सी आहेत किंवा मार्केटेड प्रोडक्ट आहेत त्याच्यामध्ये हे बऱ्यापैकी हे आयबुप्रोफेन हे असतं. सो दीज आर द ब्रँड नेम्स फॉर द ibuprofen. They are generally useful as the anti-inflammatory drug, or you can say non-steroidal anti-inflammatory drug, that is the NSAID. So here you observe that this ibuprofen, if we were to go the assay of ibuprofen, so here COH is present. So it is in the acidic in nature. COH असेल तर it having the acidic nature. So generally we are performing its titration with 0.1 molar NaOH solution. Okay, so 0.1 molar of ibuprofen with the 0.1 molar of NaOH. So NaOH is the base, ibuprofen is the acid. So it is acid base type of titration. लक्षात आलं? And here we are using the phenolphthalein indicator, which becomes red at the pH 8.3. Okay, so ज्यावेळी रिएक्शन होते त्याचा कलर आहे तो चेंज होतो. So you can say ibuprofen and the NaOH, that is the acid base type of titration. It is a simple titration. Acidic acidचा pK व्हॅल्यू किंवा डिसोसिएशन कॉन्स्टंट 4.8 आहे. ओके, सो आयबुप्रोफेन मध्ये COH आहे, सो एकच हायड्रोजन आहे, सो एकच हायड्रोजन असतो. NaOH मध्ये एकच हायड्रॉक्सी ग्रुप आहे, दॅट इज द मोनो ऍसिड बेसिक टायट्रेशन. सो त्याच्यामध्ये फक्त एकच असल्यामुळे आपण काय करतो, एकच ऍसिड रिॲक्ट्स विथ द वन base and we are getting the product. So generally what type of reaction takes place? Ibuprofen, त्याचं कॉन्सन्ट्रेशन आपल्याला काढायचं. We are reacting with the NaOH. ओके, सो आयबुप्रोफेन आपण काय करणार, कोनिकल फ्लास्क मध्ये घेणार. ओके, ब्युरेट मधनं हळूहळू ड्रॉप बाय ड्रॉप आपण NaOH ऍड करायचं. सो आयबुप्रोफेन रिॲक्ट्स विथ द NaOH. Okay, so acid base type of titration takes place and that phenolphthalein indicator is used. Okay, so जसं जसं ऍड करत जाईल तसं तसं सगळे जे हायड्रोजन आहेत आयबुप्रोफेनचे, इट विल रिॲक्ट विथ द सोडियम हायड्रॉक्साईड टू फॉर्म दी वॉटर मॉलिक्यूल आणि Na हा इथं येणार आणि सॉल्ट फॉर्मेशन होणार. ज्यावेळी एक्झॅक्ट क्वांटिटी आयबुप्रोफेन रिॲक्ट विथ द NaOH, the color changes of the indicator phenolphthalein takes place, which indicates the complete reaction of ibuprofen takes place. And from that concentration, we can find out the concentration of the drug ibuprofen which is present in the given solution. Okay. So titrant हा NaOH आहे, that is the known concentration. Ibuprofen हा titrant आहे, which is the unknown concentration. हेच कॉन्सन्ट्रेशन आपल्याला फाइंड आउट करायचं आहे. जो कॉन्सन्ट्रेशन नोन असेल टायट्रंट, कॉन्सन्ट्रेशन अननोन असेल आयबुप्रोफेन. म्हणजे आपण ब्युरेट मधून सोडतात ते NaOH सोडणार, ज्याचं कॉन्सन्ट्रेशन आपल्याला माहित आहे. सो इट इज टायट्रंट. फनेल मध्ये ज्याचं आयबुप्रोफेन आहे त्याचं कॉन्सन्ट्रेशन आपल्याला डिटरमाइन करायचं की त्याचं कॉन्सन्ट्रेशन किती आहे. सो ते कॉन्सन्ट्रेशन अननोन आहे, दॅट इज द टायटर किंवा अनालाइट, त्याचं आपल्याला अनालायसिस करायचं आहे. सो दॅट इज द प्रिन्सिपल बिहाइंड दी assay of drug ibuprofen.